Welcome to Meki Study Circle. In this video, we shall see how to simulate the milling operations using the caps mill of CADM for the part that is shown. So we need to simulate the following operations for the part diagram shown, and all these operations shall be executed on the part. So first we shall execute the face milling, side milling, followed by the pocket milling. So the data given to us is, it is a material of grey cast iron and the part load plus unload time is 10 seconds. So before we go over the creation of the geometry, now let us try to understand how the part is going to appear. So you can just see that the outer circle is having a radius of 150 mm, and also the outer circle towards the right hand side is having a radius of 100 mm. And then these two circles are connected by a tangent circle, that is outer circle, with a radius of 200 mm on both the sides. And there is a pocket of 100 cross 75 mm. It is a rectangular pocket, and it is also having a corner radius of 12.5 mm on all the four sides. So the thickness of the part is 25 mm and the depth of the pocket is 10 mm. So first we can create a rectangular blank, and then by the process of side milling we can create this particular circular blank. And then after the side milling, face milling and side milling operations are executed, then we have to execute the operation of pocket milling, and that pocket will have a depth of 10 mm. So this is how we can interpret the part drawing given to us, and with this data we shall see how to simulate the set of milling operations, that is face milling, side milling and pocket milling, using the caps mill software. Open the CADM caps mill, and now we shall click on new. So now the file setup dialog box will open, and here we shall select the material as grey cast iron and ensure the units are in mm, and enter the part load and the unload time as given 10 seconds. Select the table setup as the first one and enter the part name, and also the programmer could be the username. Click OK. So now we shall go for creating the blank and the part. So we shall start by drawing the circles. So in draw, select circle. So the radius of the circle towards the left hand side will be 150 mm. So we'll enter the radius as 150 and the coordinate of the circle as 0, 0. So now we'll create the circle towards the left hand side. So again select circle, center radius. So enter the center as 300, 0, and the radius towards the right hand side circle is 100 mm. So now you can just fit the circles to the screen. So you can see a radius of 150 and 100 mm circles are drawn. So now we need to connect these two circles by using the tangents. So we'll select tangent, tangent circle in the circle option, and then we shall create the tangents circle by selecting the two circles. Select both the circles and enter the radius of the tangent circle as 200 mm. Click done. Repeat the procedure for drawing a circle in the downward direction also. So select both the circles and enter the radius of the tangent circle to be 200 mm. Click done. So you can just see that the circles are created. So now we can use the trim option in the edit and remove the unnecessary curves and create the part. So select all the circles first, click done and trim the circles. So now you can just see that the part diagram is ready. So now this is the part. For this we need to create the blank. So now to create the blank, select draw and select shapes and select rectangle. So the total length of the rectangle will be 550, that is 150 mm plus 200 is 350 plus 100 is 'So enter the length as 550 and the breadth of the rectangle as 300. Click OK. So now the rectangle is ready. So place the rectangle appropriately, touching all the corners of the part that we have created, and click done. Blank, the rectangular blank. So now we need to define which is the part and which is the blank. We shall create the pocket. So the pocket is having a dimension of 100 cross 75 with a corner radius of 12.5. So enter these details in the dialog box and click OK. So place it at a center of 300,0. Now we have to define which is the blank and which is the part. So enter the blank thickness as 30 mm because 5 mm of material will be removing by the operation of face milling. So enter the Z thickness as -25 and then select contour and select the rectangle. Click OK. So now the blank is defined. So now we have to define the part. So for that select contour and select it as auto contour and select the circle part created. Click yes. So now this is the contour. So with this we complete the creation of the geometry of the blank and the part. We'll go to the machining window now and select the control system of the machine to be Fanuc. Click select and now we will define the operations. So select the first, that is face milling tool. Click on new tool and select the 100 mm diameter face mill tool and tell which has to be face milled. So select the blank, click done and enter the material thickness and the other cutting parameters. So we require both roughing and finishing operations. Enter the material thickness as 5 mm and change the depth of cut to 2.5. Click OK and select from which side the cutting tool has to interact with the workpiece. So now the face milling operation is defined. So now we'll go for side milling. Click on new tool. Select the tool which is having the highest diameter here, but however we need to edit the tool geometry. So change the diameter of the tool to 150 or even much higher. Click OK. Click OK again by selecting the tool material to be HSS and define the contour which has to be side milled. So now it is asking whether the contour should be milled from outside or inside. So select outside. So enter the material width and the material thickness that has to be side milled. So now the side milling operation is finished. So we'll go for creating the pocket. So select new tool and create an end flute mill and select the pocket that has to be milled and select all the finishing operations, that is roughing, bottom finish and the side finish, and enter the pocket depth as 10 mm and click OK. So now we have defined all the three operations, that is face mill, side mill and also the pocket milling operations. So now we can see how the face milling operation is being executed. So this is the face milling operation, which includes both the roughing and the finishing operations. So this is the pocket milling operation after the side mill is done. This completes all the sequence of operations, that is face milling, side milling and the pocket milling. So now we can save the file and now we can generate the important documents like the cycle, timesheet and also the spindle power graph and the CNC program for this particular simulation. Step to be followed to generate the NC program. So you can just see that this is the NC program that is generated, comprising for face mill, side mill and also the pocket milling. So this is the NC program. With this we complete the simulation of the three operations as given in the problem statement. Thank you all for watching.